Okay, so we've seen the instructions on how to solve a system of a 3x3 system of linear equations. So what we want to do now is go through that and show some examples. So first, let's do this by substitution. Okay. So in substitution, the first thing we want to do is pick a variable that's the easiest to solve for. And I think it's pretty clear to see that in the second equation here, that y is the easiest one to solve for. So let's go ahead and do that. Let's say y minus 4z is equal to negative 16. So if we add 4z to both sides, we get y is equal to negative 16 plus 4z. Once we have an equation solved for one variable, we can plug into the other two. And notice what that's going to do is it's going to eliminate the y variable from these two equations, and we're only going to be left with x's and z's. So let's go ahead and do that. For the first equation, put parentheses around the y, and plug in negative 16 plus 4z. So let's do the distribution. So x minus, 48 plus 12z plus 5z is 20. And then let's go ahead and simplify it by writing out these two terms together and then bringing that one over to the right-hand side. So x plus 17z. And then if I add the 48, we can see that that right-hand side becomes 68. Okay. Let's go ahead and do that for the second one, which is the 3x minus 2y part. So we get 3x minus 2 times, and again, parentheses, plus 9z equals 36. So what goes in here is the minus 16 plus 4z. And again, simplify by distributing and adding like terms. So 3x, this is going to be plus 32 minus 8z plus 9z is 36. So similarly, these two can be added together, bringing that over to both sides by subtracting 32. And what we get is 3x, these two together give you minus z, is equal to 4. Now, if you look at these two equations, the ones that we have, you'll notice that it's just a 2x2 system. And so we can write out x plus 17z is 68, and then 3x minus z equals 4. And to solve this, then we have
Plus c. 9z minus 8z.
oh, sorry, plus c. So this 2x2 system goes back to what we did in a previous video where we solved it using substitution and elimination again. Now you don't have to follow what you did previously, meaning if you did substitution here, you do not have to do substitution here. It can be one or the other, it doesn't matter. So I think I'm going to do substitution again because the z or the x is fairly easy to solve for. So z is equal to 4 minus 3x, and then plug into the other equation. So x plus 17, parentheses 4 minus 3x is equal to 68. And again, distribution. This is going to be, what is that? 28, 68, 30, 51. Subtract the 68 to both sides. And so what we get here is negative 50x equals 0. So x is 0. Now, just like when we solved the 2 by 2 system, once we get the x variable, we can plug in to get the y or the z value. And what you're going to want to do is you're going to want to plug this x value into a part of the equation that only has 2 variables. And you notice that up here is where we have those 2 variables, the x and the z. So let's go ahead and plug that in. Okay, so z is equal to 4 minus 3 times 0, or z is 4. And just in case you don't see, that equation is this one up here. Now we have z and x, so we can take both of those and plug it into here. Or notice that this equation in particular only has z. So it's very easy to solve for. So y minus 16 is negative 16, or y is equal to 0. So just like in your 2 by 2 system, we always want to write out how they interact with each other or where they touch. So these 3 planes, planes touch at the point 0, 0, 4. And this is written as x comma y comma z. Okay. So this is the substitution method. Now that we know the answer, which is 0, 0, 4, let's go ahead and do this doing the addition or elimination method. And you'll notice that we get the exact same result, and it is very similar to the 2 by 2 system. So the goal here, and what you're trying to do, is find a pair. So we can set them up as these 2 being a pair and these 2 being a pair, or the top and the bottom being a pair and the x and y pair up with another one. The goal, though, is to pick a variable that's easy to cancel with all 3. So since this y variable is really nice, I'm going to make this one the main. And I'm going to pair it up with the other 2. Okay, so here's the first pair, and then the second pair will be written up here. Let me write. So in this addition or elimination, remember, we're trying to add the variables together so that they cancel. So since we picked y, what we want to do is make the number in the front the same, but opposite side. So can we see that we need to multiply the top equation by minus 3? And what we get is negative 3y plus 12z. That's going to be 48. And then add straight down. So there's no x's here, so we just have an x. The y's cancel, and you're left with 17z is equal to 68. Do it again on this side. We need a minus 2 here to make the y value, a 2 to make the constant in the front the same, but opposite sides. So what we get there is 2y minus 8z is equal to 32 negative. Again, add straight down. 3x, these cancel, plus z is equal to 4. So again, notice what we get is 2 equations, both with the variables x and z, so it's a 2 by 2 system. Again, what we did in the previous video. So x plus 17z is equal to 68. And just like before, it doesn't matter which one you use. You could do another addition or elimination, or you can switch to substitution. They both work. So just for the sake of it, I'm gonna continue with addition or elimination. And what I'm gonna do is I'm gonna multiply the top one by 17, mainly because I don't wanna multiply that by 3, but for no other reason. So I'll write it on the bottom. This negative 17 so I get 3x plus z and this 4 over here. So 3 times negative 17 is negative 51. The negative 17z stays. And this one becomes 28 or minus 68. And then I will copy the equation underneath. So x plus 17z is equal to 68. Add straight down. These cancel. Minus 50x is equal to 0. So again, we get the x value is 0. And similarly to what we just did and all the 2x2 systems, take that variable x equals 0 and plug into the one with just 2 variables, the x and the z. So 3 times 0 plus z is 4, so z is 4. And then lastly, plug both in to the original, or like we did before, we noticed that this equation only has y's and z's, so I can just plug in for the z value, which is 4. So y minus 16 is minus 16, or y is equal to 0. So we can see again that these 3 planes intersect at the point 0, 0, 4.